Hello and welcome to Mr. Linford's math course. In this discussion, we're going to be continuing our talk about the application of scientific notation, but this time talking about how to perform algebraic operations on numbers written in scientific notation. In particular, we're going to discuss how to perform multiplication and division on these numbers. And we're also going to get into some applications about how we can use these operations. Now let's first go over and really define the process of performing multiplication and division on these numbers. Remember, numbers written in scientific notation are in fact numbers, right? They're just standard numbers on the number line. So we should be able to still perform the algebraic process of multiplication and that of division on these numbers. So let's take a look at these two examples. Let's start with 8.7 times 10 to the 12th times 3.0 times 10 to the 8th. These are both two separate numbers, number 1 and number 2. They're on the number line somewhere. We need to multiply them. So sometimes students think, well, let's just go ahead and turn these numbers back into their original format, right? Let's take 8.7 and move the decimal 12 places over, and let's get all these, and oh boy, this is a lot of zeros that I'm ending up with, and you know what, forget that. I don't want to have to multiply with all those digits. So we need something different, right? We need a different way of representing the multiplication process. Instead, let's take a look at this format. 8.7 times 10 to the 12th times 3.0 times 10 to the 8th. Notice that we're essentially multiplying not two things, but four things together. We're saying take 8.7 and multiply that by 10 to the 12th. That would give you your standard format number back. We're also saying take 3.0 and multiply that by 10 to the 8th. That again would give you your standard format number back. Once we get those, we're saying multiply them together. This is multiplication 4 times. Do we really need to write parentheses? Do these parentheses need to be here? Well, in fact, no, they don't. We can get rid of these parentheses. And you can reorder how you're going to do the multiplication. Keep in mind, this is the associative property of multiplication. The associative property says if you are multiplying things together, you can multiply in whatever order you want. You are allowed to do that. So maybe it's easier, instead of doing multiplication this way, why don't we reorder the multiplication? Take 8.7 times 3.0. And let's take 10 to the 12th times 10 to the 8th. Well, 8.7 times 3.0 is actually pretty easy. That's 26.1. And then we have 10 to the 12th times 10 to the 8th. This is the multiplication of like bases property. That's 10 to the 20th power. So there we go. We just multiplied the standard numbers and the tens with the exponents, and we end up with 26.1 times 10 to the 20th. We're good to go. We're done. Oh, but wait a minute. 26.1 times 10 to the 20th, that number is not written in scientific notation, is it? And why not? Well, hopefully you're saying this number is not between 1 and 10, okay? It's not between 1 and 10, so it can't be in scientific notation. Oh no, we did this multiplication and our result didn't keep the number in scientific notation. So what do we have to do here? Well, it's not that big of a deal. All that we have to do is say, okay, 26.1 times 10 to the 20th needs to be in scientific notation. All you got to do is move that decimal place over once more to get 2.61. And since you moved it over one more place, you have 10 to the 21st power. This is the same thing as this. Here is your answer. Now, this is going to be a very common occurrence When you're multiplying or dividing, your answer that you get might not necessarily be in scientific notation. You have to check to make sure, and if it's not, you need to put it into scientific notation, okay? Here we saw that the number wasn't between 1 and 10, so we moved the decimal place over. And if we move the decimal place, we got to change the exponent, okay? So that was the example of multiplication. Let's try division out. In division, you are, in fact, allowed to do the same thing we did with multiplication, where we split the multiplication. You can split the division as well. What we're going to do is take 8.7, oops, let me rewrite that here, 8.7, divide that by 3.0, and then we're going to multiply whatever 10 to the 12th is divided by 10 to the 8th. The reason for that, I like to go over a little bit of why we can split this apart. Well, hopefully you notice that these are two separate fractions, fraction 1 and fraction 2. If I was to re-multiply them, how do we multiply fractions? Well, we multiply across, don't we? We would get this right back. A longer example is if you took 8.7 times 10 to the 12th, that would be over 1, and you multiplied that 3.0 times 10 to the 8th, that would be like a denominator. And then you could split this up into 8.7 times 10 to the 12th times 1 over 3.0 times 1 over 10 to the 8th. I've seen an example where this is done. I think that's a little bit too elaborate. Really all that you need to understand is you can split up these fractions when they're multiplied together, because if you need to multiply them back, you end up right where you started. All right, hopefully that makes sense to you. And this is actually fairly easy to do now. 8.7 divided by 3 is actually going to be 2.9. And then we're going to multiply that by 10 to the 12th divided by 10 to the 8th. That's the division of like bases. So we're going to subtract the exponents and get 10 to the 4th. So is this number that we've just performed division to achieve, is this number in scientific notation? Well, in fact, it is. This is between 1 and 10, and we have a whole number exponent here. So we're good to go. This is the process for performing multiplication and division. For multiplication, reorder what you're multiplying together. For division, split the division. Reorder what you're dividing together. It's as simple as that. Now what I want to do is take some time to work on a couple practice problems. In particular, let's practice doing the multiplication and the division and making sure that the answer you achieve is in fact in scientific notation. Every answer you get, since we started in scientific notation, we want to have our results stay in scientific notation. So go ahead and try these different practice problems out. Make sure you read the signs here so you know what to do. And we'll check back in to see how you do in just a minute. All right, well, hopefully as you were working through these practice problems, you were able to come up with these different solutions. You'll notice that I stuck with the same process every time for multiplication. I reordered the multiplication each time to multiply the a values together, while also multiplying the exponential 10 values together. So I ended up coming up with 26.732 times 10 to the third, and I also produced 23.8 times 10 to the 22nd. Now notice these numbers are not in scientific notation. I need to again move the decimal place over. So I should receive 2.6732, and here it should be 2.38. Now I'm going to multiply these by 10 to the, and notice that I'm going to have to change the exponents here. Before, for 10 to the third, that meant I need to multiply the decimal 3 places. But since I'm starting here now, I'm going to have to multiply it 4 places. So let's go ahead and let's write 10 to the 4th power. I've added 1 because I moved it to the left. And again, let's add 1 here to be 23 because I moved the decimal to the left. Now, for the division, you'll see that I first wrote it in this more fraction format, just so it was easier to see. Then I split the fraction up and performed division on the numbers, and then division on the tens. When I divided 1.5 by 3, I got 0.5. And when I divided 10 to the 13th by 10 to the 9th, I got 10 to the 4th. I just subtracted their exponents. Again, this number is not in scientific notation because this is not between 1 and 10. So this time I need to move the decimal, but I need to move it to the right. So I am going to end up with 5.0. You could also have just written 5 here, but typically we tend to include a decimal point just because. Now, since I moved it to the right, I'm going to subtract 1 from the exponent and make it 10 to the 3rd. Hopefully you can see why this is. If I had 0.5 times 10 to the 4th, that means take 0.5 and move the decimal 1, 2, 3, 4 places. So I end up with 5,000. Here, since I already moved the decimal to now start right here, I don't have to move it 4 places, I only have to move it 3 places. So 5.0, I move it 1, 2, 3 places, and end up with 5,000. Okay? This just goes back to our original statement. If you move the decimal to the left at all, you add, you increase the exponent. If you move the decimal to the right, you have to subtract away from the exponent. Hopefully you get this process down and you're comfortable with this, how we move the decimal and how that affects the exponents. Again, if you're not entirely sure, go back to our process that we wrote down when working with scientific notation, the exponents, and really make sure we have down when you move to the left and to the right, how that changes your exponents. Now let's get into an application problem. Here, let's talk about something from astronomy. And we're going to discuss the distance between Earth and the Andromeda Galaxy. Now, Earth is a part of the Milky Way galaxy. That's the galaxy we are in. The Andromeda Galaxy is a separate galaxy. And it's one that's, I believe, is estimated to be on a path to colliding with the Milky Way galaxy. So, but that's not going to happen for probably a couple billion years. So, the distance between Earth and the Andromeda Galaxy is approximately 1.8 times 10 to the 6th light years. Okay, that's our unit of distance, light years. Assuming that 1 light year is this many miles. Okay, so let's pretend we have this picture here. Over on the right, we have planet Earth. And over on the left, this collection of colors, let's just say all these are a bunch of stars, planets, whatever. This is the Andromeda Galaxy. Now the distance between these two locations is 1.8 times 10 to the 6 light years. We want to figure out what this distance is in miles, okay? Now, how are we going to go about and doing this? Well, sometimes when working with scientific notation, I think it's helpful to reformat the problem, this time with regular whole numbers, and very simple whole numbers, okay? Let's pretend the distance between Earth and the Andromeda Galaxy is only 4 light years. So what I'm going to do is I'm going to chunk up this distance here into 4 relatively equal pieces. 1, 2, 3, 4. Now, each of these distances is 1 light year. And 1 light year is, let's just say, instead of this whole unit here, let's just say it's 6 miles. Okay, let's just pretend 6 miles. So this is 1 light year, and 1 light year is 6 miles. But you actually don't have just 1 light year, you have 4 of them. So how many light year or how many miles are there for the 4 light years? Well, if there are 6 miles for 1 light year and you have 4 light years, you're going to end up with 24 miles. So That's the general setup to this. And that should make sense. If you have so many miles for a light year and you have this many light years, we just multiplied them together. So now let's reformat the problem, but this time let's try it in terms of the actual values. Okay, the real distance between the Andromeda Galaxy and Earth is roughly 1.8 times 10 to the 6 light years. And each light year is about 6.0 times 10 to the 12 miles. So 1 light year is 6.0 times 10 to the 12 miles. This many miles per 1 light year. Well, you have 1.8 times 10 to the 6 light years. Again, this problem is set up the exact same way as before. You know how many miles there are in 1 light year, and this is how many of them you have, so we're just going to multiply them together. So we'll end up with, oh boy, 6.0 times 10 to the 12 times 1.8 times 10 to the 6. Well, let's multiply 6 and 1.8 together. And we'll end up with 10.8. And then let's multiply 10 to the 12th and 10 to the 6th together. Let's see, we're going to add the 6 and the 12 to make an 18. So we have 10.8 times 10 to the 18th power. But again, this is not in scientific notation. We need to move the decimal place 1 over. So we have 1.08 times 10 to the, and since I moved it over to the left, I'm going to add to the exponent 10 to the 19 miles. 1.8 times 10 to the 19 miles. This is how many miles it is between Earth and the Andromeda Galaxy. That is what 1.8 times 10 to the 6 light years is in terms of miles. All we did was we just multiplied the units together, okay? Hopefully that's making sense to you, and hopefully you have a technique for when working with these scientific notation problems. Sometimes it can be difficult to wrap our brains around them. So what I do is I just do an example where I do the same setup, but this time dealing with much easier numbers, much more simple numbers to work with. Once I do that, I can kind of see the general format to the problem so that I can do the same thing, but this time with the more complicated numbers. Hopefully this is making sense to you, but if you have any questions or comments about the video, please let me know. Feel free to email me. My email is klinford, that's K-L-I-N-F-O-R-D, at wccnet.edu. Let me know what you thought or if you have any questions, and until next time, take care.